We built a lot of houses that really have been designed to fall apart without meaning to. No one intended for a house to do that. But we've got a huge investment, the biggest investment that most people ever make in their lives, a home that might last 30 or 40 years. When you look at the construction industry, it's really one of the only main large worldwide industries whose productivity has gone backwards since 1965. And we're doing something and trying to preserve something that really needs to go away.
Construction productivity has gone backwards since 1965. Every other major industry has gotten more efficient. Construction has gotten worse. And we're still building homes the same way, without a real understanding of building science, without thinking about longevity, and on a cost-based race to the bottom that gives nobody an incentive to change. The result is that the biggest investment most people ever make might only last a generation. Today's guest, Kyle Hanson, decided to build a company to fix that. Kyle's the founder and CEO of TAMBS Systems, a vertically integrated CLT building system manufacturer that builds homes designed to last hundreds of years at prices competitive with a standard code-built house. Here's what we got into today. First, how did we get here? The building science and market dynamics that created a housing stock designed unintentionally to fall apart, and why the industry has been too stuck to fix it. Second, the system. What the timber age building system actually looks like. Exposed CLT panels, an air barrier, dense packed cellulose, weather barrier, and pre-installed windows, all factory built and shipped ready to install. The result is a complete high-performance building system that goes up while your foundation is still being poured, gives your crew one trip around the building, and hands your finished trades a closed, weather-tight shell to work inside from day one. Third, the build. How a crew of 4 closes in a house in just 3 days and cuts total construction time from the typical 8 months down to just 2. If you're a builder, architect, developer, or just somebody who thinks housing could be done a lot better, this one's for you. Because as Kyle sees it, we don't have a housing problem, we have a building problem, and those aren't the same thing. So with that, let's get into it.
We built without really thinking a lot about how buildings worked, from a moisture and an air movement and all of those things that had to do with longevity. And in many ways, we kind of lucked onto a great way of building because we stick frame things, and then we had small amounts of insulation, and we had fairly open buildings, super drafty, right? So historically, in the winter, we would shut off an entire half of the house or whatever, so we didn't have to try and heat all of it. And then along comes our understanding of insulative values and starting to think about air movement through buildings. And we kind of missed it or misapplied it, probably from the 70s. Some people are still, I would say, building very, very poorly. But at least 70s, 80s, and 90s, we built a lot of houses that really have been designed to fall apart without meaning to. No one intended for a house to do that. But when you put a condensation layer inside of an envelope and then people cook and shower and respire inside and the moisture goes out and settles in a spot and drains down and starts rotting things, we've got a huge investment, the biggest investment that most people ever make in their lives, a home that might last 30 or 40 years. So sustainable, I think at the core means hopefully you and 5 more generations get the chance to use something as important and as large of an investment as a home.
And then what about the effects that those types of materials have on the people inside of them in terms of like direct health, maybe a little bit of like cognitive well-being, et cetera. But like, let's start with like physical health. Like what role do sustainable materials play in that role?
I think it's probably semantics, but I would guess that sustainable doesn't necessarily mean healthy. I think there's probably an interplay between the two. But I think we can say, right, if you've got hundreds of thousands of years of things evolving together, that natural which oftentimes is related to sustainable, probably relates back to healthy. And like one of the things that we talk about, and the wall panels behind my head, they have variable permeability, which is something that people sell. And when we make building membranes, people want something that changes automatically in terms of how much moisture and how fast it lets it through. Wood does that naturally. And we don't have to engineer anything. It's just designed that way. So it has variable permeability. It automatically stores and releases humidity. So it's hygrothermically, buffering for an environment. Something else that's really important for us to try and maintain consistency in an environment, and wood is doing that automatically as a building material. And maybe kind of the last thing is, at least in terms of helping us say, when and where does air move in and out, and what kind of quality is associated with it. Wood, in the case of what we build, because we're building with solid wood panels, it's a really great way to just naturally control the movement of air so that the air that comes in can be filtered and controlled and monitored, and that we don't have air moving through that's unplanned or is moving through and picking up mold spores from, those rotting sill plates that I talked about earlier.
Yeah. And then the other thing, and this is just because we've gone through this experience, is what's not being introduced into the home by selectively choosing your materials, right? So if you're using wood panels versus, let's say, an off-gassing VOC paint over top of questionably sourced drywall, right? Like those are all other health factors that you're kind of removing or at least mitigating when you're choosing these kind of bio-based materials, at least in my opinion. What do you think?
I completely agree. I think the really cool part is if you're on the inside of a house, you really don't have, if you didn't do anything to it, you would have a naturally antimicrobial surface. And there's cool research happening in Oregon around the use of wood in hospitals and laboratories. And we're realizing that, stainless steel is awesome, but it's really difficult to keep clean. And so if you aren't completely meticulous about the way that you clean it, you lose the ability to have that be antimicrobial, and things will actually grow there easier than they will grow on a wood surface.
What do you, by choosing, let's call it bio-based materials, wood, et cetera, like what are you avoiding introducing into the home that could potentially be harmful?
Yeah, this is a great question, because if we pick a material that doesn't naturally have a beautiful surface to look at, the ability to naturally monitor and buffer humidity and air movement, and perhaps even be antimicrobial, you have to add those things. And we're usually adding those things by layering in chemicals or layers and the interactions of all of those that we don't normally even think about. One of the things that I love, we happen to use this material, cross-laminated timber, in our homes. But cross-laminated timber usually is 1% or less by weight glue or adhesive. OSB, or plywood, some of the other things that we're used to might be 15%, 10 to 15% glue. So just the closer we can get to using whole tree or large components of trees in board form, I think the closer we are to nature and all of the things, all of the advantages that have already been created through years and years of evolution.
So we've laid out a little bit of, what is sustainability? What does high performance mean? And kind of like the impacts for the occupants inside of the buildings. The question that leaves me with is, why aren't we doing all of that right now already? Like, what are the challenges that we see in the building industry?
Man, I was just talking to some folks about this the other day, and we have this great group of builders in our region. We're in southwestern Colorado. We have an office in Durango, and our manufacturing is in Mancos, Colorado. There are some great sustainable green builders in this area doing great work. And And in our conversations, they love our system. They're 5 years out. So they could do everything exactly the way that they've been doing it. There's no risk of change. There's no retraining involved. They just keep cranking out what they've been doing in the way that they've been doing it. And so in some ways, I keep thinking, that's actually a great sign, because it means that there is value in the approach that we're doing and the way that we're chasing both, sustainability and operational efficiency. People are paying for it. At some point, there will be some pressure, hopefully, or we'll get better at telling our story about the advantages that come with our system, and it will become worth switching. But I think in some ways, like, the biggest thing is that people value it. It's starting to show up, and they don't have room in their schedule to explore alternative ways or alternative systems of approaching or solving the same problem that they're getting paid and getting backlogs to solve right now.
For sure. And I hear that a lot, right? Because like everybody knows we're in a housing crunch, a housing shortage. We need to build more housing. And so it's like, okay, well, here's something new that you have to take time to go learn and explore and figure out all the nuances and intricacies. And they're like, hey, we just need to keep building more housing the way we have done. So I totally understand that. On the other side of that, I often hear people, especially when I'm talking about your guys' systems, what's possible with, high performance, sustainable housing in general. And they're like, yeah, all that sounds great, lovely and wonderful. It's 4 times the cost to build a high performance level house. What would you say to that?
That would be the other thing. So, and I think it's related to what we were just talking about. So if we say the people who are probably the most conscientious and thoughtful in providing the highest value houses, if they love sustainability, that's probably a great value. And if they adopted our system, it would be something excellent. Then there are the group of people that are building in between, and the way that they are capturing market share is cost-based. And I think anybody that studied economics understands that if your sole differentiator is cost, it's not a very good thing to base a business model on, because it's just a race to the bottom. And that's, I think, in the long run, that's part of why building stays and continues to be inefficient and still have costs rise, is because we have people competing on cost, which means that they grab market share, they have a period of productivity, and then they're driven to a point where they go away because there was no differentiator, that allowed them to be able to have market relevance. So cost is this really important piece. And I think we all understand that sustainability, efficiency, right? You can quantify that from a monetary standpoint, but sustainability is a hard one because it's a long play. It's kind of like stewardship. It has to be values based. And I think the research says that, people will pay for values, sustainability being one of those, for, maybe usually between 3 to a ceiling of 10% premiums. That had a lot to do with the way that we were thinking about this. And one of the unique things about the way that we're approaching it is because we are vertically integrated, it allows us to be able to have a raw material that typically would not be affordable or maybe even the best fit. And it allows us to be able to control costs such that we're, and at least in our region, cost parity, or actually, in some cases, even less than a code-built house.
And so you're saying that, purely writing off sustainability and high performance because the assumption is that it will always cost prohibitively more is a false assumption, at least in the scenario that we're talking about.
I think it is. And it's one of those places where I know that it feels difficult, and there's a lot of industry associations that advocate against energy code changes. It's one of those places that is going to end up probably taking us to much better places from a built environment standpoint. Because as energy code changes, the way that we've always done it is eventually going to become untenable.
Yeah. Yeah. So you've kind of alluded to it, like some of the things that make it, or that make timber age uniquely suited to kind of address some of those concerns. Let's peel that back a little bit. So I guess give me a little bit of context on like how you guys are vertically integrated, what you guys do, how you're able to design, develop, and kind of come to the end conclusion of this sustainable, high performance, durable house. Like kind of walk me through Timber Age's model.
Okay. I talked just a little bit early on about the idea. So it's always worth mentioning. Our mission is elevating communities and healing the environment through innovative materials and methods which transform the ways we build. So the material behind me, mass timber, cross-laminated timber, is a way to be able to accomplish the mission and the place that we're at and the time that we're in. And it feels like a good fit. It's a vehicle to be able to solve that. So knowing that the idea is how do we just keep fulfilling that? And we were pretty intentional and we said, healing the environment through innovative materials and methods. We know that we can't keep doing it the same way. And I think sometimes that's a trap that we fall into, is we keep trying to say that the way that we're doing it is worth preserving. There's a great graph. I'll send it to you so you can look at it. But this productivity graph that's existed, tracing basically $100, they set the index in 1965. You spend $100, you get $100 worth of value. When you look at the construction industry, it's really one of the only main large worldwide industries whose productivity has gone backwards since 1965. Where the work that, especially that we've seen from the evolutions in the manufacturing sector, the Toyota production system, and all the different ways that that's been adapted, or that we've seen scale in the ag side of things, all of those things have infinitely driven up, productivity. Where the construction industry has stayed the same. So it's this weird thing that we keep saying, man, we just need people swinging hammers, and climbing ladders and walking rafters, and we're doing something and trying to preserve something that really needs to go away. But there are so many pieces in it, and there are so many stakeholders that I think it's just scary and it's overwhelming. But we have to let bigger visions drive innovation in the industry. We shouldn't be pushing them off. We shouldn't be saying it's a bad thing if our houses get more efficient and the cost of energy to heat and cool goes down over time.
So we've kind of established that the construction industry productivity is flatlining or declining over a 60-year period. Let's kind of break that down a little bit. So from the outside looking in, you have a few different components to what goes into what we'll call like building a building, right? So you have government, regulatory, permitting, zoning, all that kind of stuff. Then you have labor, and then you have materials, and then you'll have what I call like the design process, right? Am I missing? And then financing, of course, but I don't think that it's gotten harder, at least in my opinion, to finance anything to get built over the last 6 years. If anything, I'd say it's gotten way easier. So let's unpack the first one. Like, what in terms of labor are you looking at to improve the construction industry, specifically with the Timber Age model?
When it comes to labor, I spent my summers through high school and college working in construction. I started with doing concrete work and roof tear-offs and stuff, and ended working on a framing crew. The first thing that actually comes to my mind is, if we're trying to care for communities, at the heart of communities is people, and that means that we're trying to take care of people in a way that preserves their safety, gives them fulfilling work, and gives them dignity. And the way that we have done construction, I was talking with someone about this the other day, where I was like, what other industry would you ever let people be on ladders, running around on roofs? I mean, the stuff that we let or even expect or reward or even give badges of honor to in the construction industry are kind of messed up, because we wouldn't let that happen anywhere else. And I think we can also see that we are we're doing workarounds all over the place. And the first one is by having people that work for us consistently, and we keep them as 1099s or contract workers, because we know that there is so much risk associated with what we're asking them to do that our cost models wouldn't work if we actually had them as team members and paid workman's comp and all the other components.
Right.
So I think, and that's why I think we see in the framing, profession especially, that for every one that joins, 4 or 5 leave. It's not rewarding work. They're the first layer that is always exposed in the way that we're doing the work of building a house. And I think that it could be a much more rewarding job for them if they were in a place where what they were doing was safe and they had more time to think about the value that they're creating versus just trying to make it through a day safely.
And so with the timber age model, how are you guys reducing that need or status quo?
One of the goals that we set when we were designing the system was, could we set panels and only have to make one trip around the building? And so that meant, when you think about all of the times that in the current situation that we might, just pick a square foot of the wall, how many times is that square foot being addressed from one side, the interior or the exterior? How many times is it being looked at, And so it's air, and then it's a couple 2x4s or 2x6s, and then someone's there putting a membrane on it. Then someone's on the inside putting insulation up. Then someone, is running electricity. I mean, you think about the number of times, and, it's all the way from the floor all the way up. So if you think about most of the time, we used to talk about it's from your hips to your shoulders is kind of that ideal workplace. If you're trying to care for people ergonomically, look at a wall and think about how much work has to happen on that wall and how much of it happens between the waist and the shoulders. It's so little. And then the rest of the time we're having to augment. So then people they're on scaffolding or they're on ladders or whatever. So we were like, okay, we have this thing laying flat on the ground. How many of those things could we do in a way that lets people address and solve all of those problems ergonomically, so that if we put up the scaffolding, we put it up once and they're stitching the panels together and they're putting siding on and they're moving around and they're up off the ground one trip around the house. Just that is a big, big way of taking care of people and taking people out of harm's way. If the roof panel that we put up there doesn't have holes in it, if we're not, if we start with something that has a walking surface that you could tie off to, I mean, that's a very different thing than having people up tipping in rafters, in a traditional approach.
Yep. And that's going back to like what you guys do, and that's manufacture building component systems. And those are my words, right? But panelized systems that have all of that labor that used to be, step 1 through 100 on each wall. You guys are doing that offsite in a controlled factory setting, so that when it gets to the building site, all of that is already done. It's simplified. It's safer. And so when you're putting together these panel systems, it's like you don't have 100 different steps in the adverse conditions and heights. And like you said, walking on rafters and scaling ladders and stuff like that. You guys are just literally picking and setting, prefabricated panel systems already. That's what that.
Yeah. We've been talking about like, how can there's all these kind of fun goals that you can set for yourself. I think we still have to use usually 2 to 3 bit sizes, Torx bit sizes, just because the different sizes of screws that we use. But if you can run an impact driver and you can use a caulk gun, you can probably put together one of our buildings. I mean, two main tools happening. Now, I guess the other side would be like a press fix, and you need to just understand how to put tape on and those kinds of things. But man, if you can pull screws out and drive screws in and you can put a bead of caulk down, that is a lot simpler than what we're asking people to do. And with that exodus of framers that I was talking about, I think one of the biggest challenges, we don't always think about it, is we can't get a building loan for soft costs. And the reason why that matters is because historically, we spent the least amount on the design process possible. And the way that we did that is we took a tremendous amount of detail out of the plan sets that we use for permitting, because we know that you could give this very, very minimal amount of information on a drawing set. And then so I paid less for the drawing set. I'm going to pay a lot more for the expertise of the master framer that's going to interpret that and lay everything out for the rest of the people that have only been framing for a year or two. And the reason that we live without waste is because I can get a loan for the framer. I can't get a loan for the architect. So if we just assume that we're trying to get more and more and more of the design intelligence into the hard costs of the project, us absorbing those design costs and those design rules and the wisdom of all of those things into something that we build in the factory also gives people more purchasing power than they would typically have and more flexibility in the use of our system.
Talk to me about what you guys are doing differently with the materials that go into a building. Like, let's unpack the cross-laminated timber angle, and then where you guys are sourcing the fiber, how you're putting it together, and how that is contributing to the material input efficiency of building systems.
When it comes to the natural material that we're using, the ponderosa pine and these panels, really the problems we're trying to solve is how do we get a load-bearing component that is monolithic, and we'll talk just a little bit about that, because if we use randomly or non-randomly, if we have a stud every 16 inches, from a building science standpoint, we put insulation between the studs, and then in higher quality building, they'll usually at least do a continuous layer of insulation on the outside. But the way that a wall works and the way that moisture and sound and heat moves through any solid surface, the more variability and the more pieces that you use in that wall, the harder it is to predict how it's going to work over time. So one of the things we gain by starting by saying, Our problem in our forests is we have lots and lots of wood, way more wood in the forest than we need. If we leave it there, it's likely going to turn into a catastrophic fire event. So the problem we're trying to solve is, how do you get the wood out? The place that it ends up working beautifully is, let's use it structurally to create a single surface that's 3 inches thick everywhere it shows up. And now all of a sudden, the movement of air, sound, moisture through it becomes really, really easy to understand and predict what it can support in a compression standpoint. So if we put it in as a wall, it's much easier to understand 3 inches of solid wood than it is to try and calculate studs of different strengths or predictable strengths every 16 inches or every 24 inches or whatever it is. So in a weird way, by doing something monolithic, we're actually simplifying everybody's ability to predict how the building is going to work, not just at the outset, but potentially over time, which is why we can think about our buildings, lasting 100 to 200 years easily, because there's just not as many failure modes. There's only a few places where moisture has the ability to move through or air does. And so the fewer the places that you have to try and control, the easier it is to control it, because it's just probability. If 1% of the connections are going to fail and you have 5,000 connections, that's 500 places where you're going to potentially have to go fix something. If we can reduce the part count in our building, by 100%, now all of a sudden we have 500 pieces. Now it's just 5 spots that we have to think about. So our ability to make something of high quality with the ability to guarantee the quality goes up significantly simply by simplifying the way that we put the house together.
And let's talk about what this, you talk about that monolithic structure. That's what cross-laminated timber panels are. For somebody that doesn't know, give me the high-level view of like what a cross-laminated timber panel is, how it's made, and then we're going to pivot into because that is a manufactured monolithic piece, how that might change a little bit into the design process of building a house. But first, I guess, give me the high level of what cross-laminated timber is.
Yeah, for sure. So for timber age, we have overcrowded forests. We buy logs from a number of different sources. A large portion of it comes out of national forests because in Colorado, the majority of forested land is either state managed or federally managed forests. So we buy logs. We have those logs cut at 11 feet long. And the reason that we do that is so that we can use more of the tree. In a typical prescription, people are, buying something based on how big the small end is. So by us being able to use 11-foot chunks, we can actually use more of the tree that normally wouldn't make it out in a saw log or a whole log kind of operation. So we buy 11-foot logs. They go through a sawmill at timber age. They're made into boards. The boards are sorted for 2 common and up. And then those that are, 3s or below from a structural standpoint, those boards go into a kiln and they get dried to 12% moisture, plus or minus. And that's important because the industry is at least standardized around the adhesives and the use of a starting point of 12% moisture plus or minus 3. We dry the boards. And then now that we've basically removed most of the reasons why the board would have a unpredictable result. So we've taken out all of the knots and now we've dried it. It's dimensionally stable. At that point, we actually turn it into a very, very tightly controlled rectangle with all the rectangles being exactly the same thickness, which is really important for us to be able to take a long layer and then turn the boards 90 degrees, put another layer of boards at 90 degrees, and then turn the boards again. And each time we create a layer, we're putting a layer of adhesive down. So we end with 3 layers, in our case, 3 layers of boards that are that add up to just about 3 inches. And it's 3 layers thick. Each of those layers is called a lamina. And we went from something that is natural and tends to move because the grain changes shape and length based on moisture content in a single board. But by randomly distributing all of those boards and the defects and the movements that they want to make across 3 layers and random boards, all of a sudden, all of those forces are just kind of equaling each other out. So now we have this 3-inch thick monolithic slab that because the defects are randomly distributed, it went from having something that might twist and turn as it goes through time to something that stays plus or minus 1 millimeter over time.
So you're dimensionally stabilizing all of the boards because we all know that when we buy a 2x4, it warps, wanes, it twists, et cetera. But because you guys lay up all of these boards in a panel, glue them together, that kind of holds dimensional stability. Like you're not going to end up with a 3-layer panel that's warping and waning and twisting because all of those different forces are now kind of like bonded together and counteracting each other. Is that fair?
Yeah, that's exactly it. It's really kind of a fun. You wouldn't necessarily think about how well it works, but we utilize that concept in composites all the time.
And then, so the panel is it is the backbone of your guys' system and what you're looking at, but it's not just the panel, right? Like we alluded to earlier in the conversation, like it's all of those other follow-on trades and tasks that you're also looking in the building system. So at Timber Age, once you have the panel, then what do you do to it to kind of get that prefabricated panel assembly that we're aiming to install on site? What else goes into that process?
Great question. Yeah, so we call the Timber Age modular building system. Is kind of the collection of all of these components. So we have something that's going to be able to hold the house up. Like you get to stack stuff on top of it. So we do have that structural component, and I alluded to earlier, it's also a component that if you put up a 2x6 wall, there's a lot of air moving through it. And so you're going to have to manage, how do you control air movement through a 2x6 wall? You got to put something else on. You got to sheath it or whatever. The other thing that we get when we put the sheathing on a 2x6 wall is we stop it from tipping back and forth or racking. So one of the really cool things that we've done, we start with this 3-inch thick, solid, monolithic thing. We've already taken care of shear or the resistance to racking. We've taken care of compression or the ability to hold things up above. you've got this surface that you can put a screw anywhere if you're going to fasten things to the inside or the outside of it. Right. So we get this really, really flexible fastening surface that's also been handled. We also have this ability to absorb moisture inside the house and release it. So that would normally, you might have to use a humidifier, or you might have to use a lot of other tools to try and control moisture. We actually have a material that's helping us keep the moisture content of the house consistent. And, last but not least, we have some insulative value. And so there's some resistance to the movement of temperature through the wall, about 1.2 per inch or 1.2 per inch. So maybe our 3-inch, thick CLT slab is giving us R4 in terms of resistance to the movement of it. The other really cool thing that also happens, though, is because it's of the tightly packed molecules in the wood, it regulates the speed of how fast something moves through. And so we call that thermal mass. And when a temperature changes on one side and that temperature change doesn't show up for a period of time through a material, and it could be anything with mass, concrete, glass, anything with lots and lots of molecules packed in, we can actually thermally shift when temperature changes show up. And where we live, we have big temperature swings through the day. It might be 40 degrees at night, and it might make it to 95 degrees during the day. If we think about those temperature changes moving into the house at night, if our phase shift is 8 hours, we might have that hot day shows up on the inside of the house 8 hours later, and it's 40 degrees outside, and you actually might need to be turning the heat on inside the house. If it's cold, right, we might want to warm that up. So that phase shift actually has value as well. So that's just the first 3 inches. Then we're going to try and say, how do we make sure that we're controlling and protecting as we move out? So there's a layer, kind of a belt and suspenders. Even though the CLT is keeping air from moving in and out, we'll put a membrane on that allows us to guarantee exactly how much air moves in and out of the material. So we have 3 inches of CLT. We have an air resistant or air control barrier. And then because we only have R4 and we want to make sure that we have the ability to not have a condensation event anywhere inside, we add insulation. And when we're adding insulation, we're actually doing 2 things. We're creating the void using wood eye joists that tie, our panels are 5 feet by 10 feet, which is, there's all sorts of good reasons why from a manufacturing standpoint, but it's kind of small. So how do we take our little 5 foot by 10 foot panel and turn it into something that's bigger that you can have fewer crane picks? So typically our 5 foot by 10 foot panels are going to be fastened together edge to edge to maybe make a 10 foot by 20 foot chunk. Big Lego block. So we'll use wood eye joists to tie all of those individual panels together. And because there's now 12 inches of space, we'll put a weather-resistant barrier on the outside of that. And now that empty space between our air-resistant barrier and our weather-resistant barrier, we fill with dense packed cellulose and get the ability to have recycled materials show up in our panels. It's a Class A fire-resistant material, so it makes it more fire-resistant or fire-hardy. And last but not least, it's providing R48, which means as the temperature change moves in or moves out, we'll never have something reach dew point inside of our assembly. And the reason that matters is if you have a 2x4 wall that's full of insulation, it's R19 or whatever, you will have moist, warm air moving from the inside of the house to the outside. It's called vapor drive. And if there is a layer inside that warm, moist air hits before all of the water has a chance to turn to vapor, so it's 78 in your house or 72 in your house and you're taking a shower, that warm, moist air goes out. And if it hits your Tyvek or your siding and before all of those molecules have a chance to spread out, it'll condense into liquid water. And as that liquid water collects, it runs down, and it usually collects at the bottom or some spot, some layer inside there. And none of our building materials in most cases are meant to just have standing water on them, especially the ones inside of our walls. So we've gone from kind of all of those fun problems that we're solving, a whole bunch of them that get solved just by the use of the cross-laminated timber as that first layer that's structural, shear, air control, humidity buffering, all of those fun things. And it's just great to look at. We didn't have to cover it with paint. We didn't have to put drywall on it. You can see I get excited about this stuff,
Yeah. So you guys basically take it from interior finish on the inside to cladding-ready on the exterior. And then you take them to site, crane pick them in, bolt them all together with screw guns, a couple beads of caulk. And then that's your envelope. That's your structure, right? And some of your finished stuff on the inside. How do you address running like your MEP and stuff like that with your system?
We've approached it several different ways. It depends on the municipality that we're in. There's certain folks that have been very interested in what we're doing. So an inspector might come actually look at the panels when they're open and watch to see what we're doing. And we'll just document every single panel and what the interior of the movement of electrical in our panels. When it comes to any of the external panels of the building, we would typically never put plumbing inside those. We would say that plumbing should stay on interior service walls, but we could move the wiring or the electrical component either directly on the outside and then bring it in, or we could machine chases in. So it depends on the municipality that we're working with. As we move into the future, Colorado's made some really big improvements in terms of their ability to certify offsite panelized systems. And so we're currently pursuing the ability to have our panels certified. If we can get to that point, then they can do remote inspections and we'll be able to move to panel electrical on everything that we're doing. And we won't have to do the separate chases on the interior. There's pluses and minuses, but I would say those are the two main things. We could, if it's a municipality that we have a relationship with, we could embed it, and it comes actually, you can see like right here, where that's going. But so it could look like that, or it could have a chase with a trim board.
Got it. And so we've talked about all the systems that go into like creating the structure itself. Let's take ourselves and put ourselves in like the homeowner's position of like, hey, I love everything that we talked about the why and the how. What constraints, if any, do you have with working with homeowners? You say, this sounds awesome, but if it's coming out of a manufacturing facility, do I have to buy the same box, the same shape, the same layout, whatever? Like, what options do people have to like make it a home rather than just a standard off the shelf product? Like, what are you guys able to do in terms of like the design of the homes?
Okay. Yeah, that's a great question. So I think we've talked about one of the problems that we know that we're solving is affordability. And so if we're trying to provide the ability to give people affordable houses that they can use their bank loan for, there's a degree of repeatability that is typically going to be a component. We know that we can change the color of our car. We're not going to change the shape of it. But because we know that we're getting something with high quality at a competitive cost, we're willing to give up some flexibility. So I think that's a key component of us trying to make sure that we care for people that are in a spot where they can't afford flexibility. How do they just get something predictable and still great? So I think that's a component. The other side of it is if you do want flexibility. So because our base building block is 5 feet by 10 feet, we've tried to make it really simple for people to make go, no-go decisions. And the way that works right now is you're going to pay in 50 square foot chunks for your building. Now, that could mean that you use a wall that is 15 feet long. Or if you choose to make a wall that is 12 feet long, we can make that just as easily, but you're going to pay for 5. So what we've tried to do is say, make it really simple for people to be able to optimize to get the best value out of what they're paying for in our system. Because whether it's whether it's 5 feet or whether it's 3 feet, we're still going to have to do the same amount of machining and all of those components to it, right? So going back to, we're trying to make it easy for someone to look at it and say, at a gross level, how easy is it to price our system? And it's pretty easy to price because you can just break it into those chunks, and that's what it's going to cost. It's also easy for them to see where they could optimize because you can see where you're using partial components. Last but not least, I would say that we're trying to allow people to be able to make a decision that allows someone else to be able to learn from it. So maybe that doesn't have as much value to that person, but if they believe in the mission, we have a way of designing the houses that's trying to capture all of the learning, all of the optimization, all of those learning pieces for the next person that's going to come down the line.
So somebody that, like, they don't have to come to TimberAge and say, TimberAge doesn't say, here's our 3 standard floor plans. That's not how it works. It's like you come to us with what you need, and we use our system to work within your vision, and then we just optimize based on certain dimensions. Is that fair to say?
That's totally fair to say. We can build anything, but building anything may not satisfy all of the components of value to you.
Got it.
And so we're trying to give people, and in fact, that's a big key for what we're trying to do right now. Almost everything we've done up to this point has been bespoke, but we've got a Wood Innovation Grant and a really great group of designers that are working on repeatable designs that we'll be bringing to the world fairly soon on timberagehomes.com, which is exciting.
Yeah. Talk to me about the construction process now. So somebody's optimized their layout, they got their floor plan, you guys have made all the components, and it shows up on the job site. How different does that job site look in terms of a traditional stick frame home, let's say, and how much faster is it?
It's probably just worth mentioning that one of the great things that was happening is we were building the skeleton, the exterior of the house, while they were building the foundation. And so anytime that we're doing offsite, that ability to parallel process those 2 components is a big key to shortening the overall lead time because they're not sequential anymore. They get to parallel process. So the best part is we're pulling up with a trailer to a foundation that was being constructed and is now complete, ideally at the same time as we got the panels ready. So we have a crew of a crane operator and 4 to 5 folks that are going to show up. Because every building that we do has a digital twin, we've been able to show people in animations exactly what the process and the sequence of building looks like. Because we can show them the sequence, we've been able to actually script the process. So when you show up from TimberAge, you're going to get training in, if you're operator 1, here's what you're going to be doing with your time as we go through each of these sequences. And we kind of break it down so that you can see an assembly is what we would call that bigger collection of, let's just say it's 4 individual smaller panels, and now it's 10 feet by 20 feet. So that assembly, someone's going to be laying out screws and prepping that. One person might be preparing the caulk and the air barrier so that we have that continuous air barrier that goes through the system. Another person's going to be rigging it. Another person is going to be doing quality checks. So as you go through, you've got this team, and usually by the time that we've made it through the first half a day, a team is typically setting one of those assemblies about every 20 minutes, which means that in general, the construction from a foundation up happens about 800 to 1,200 square feet a day, which means that your average house is typically going to be assembled and people are going to be working inside 2 to 3 days from the time that the trailer shows up and the crane starts moving. And then we go into that mode of, can we get around the outside of it, in one pass? And depending on the number of people and skill levels, that's probably another 5 to 10 days of work, and someone's going to put a roof on it. So if you have a dedicated team of, 4 to 5 people, theoretically, you could have that house completely dried in and finished in some cases in 2 weeks or less.
Wow. And when you say finish, talk to me about what that finish level encompasses and what it does not.
I would say that if we've shipped the panels with the windows installed, really you have a person who is putting two panels together. There's a gap there that needs to be addressed. So they're going to put a spline in and drive some screws to make sure that everything's tied together from a bigger shear component. They're going to stuff it full of insulation. They're going to pull a WRB over and put a rain screen batten back on. And once that's done, the person that's doing the siding can really start, whatever that component is, can start following them around. So typically that's what it looks like. You have one or two people that are stitching and stuffing and sealing the panel joints. And then you have, two people that are following them, probably putting siding up. Let's just say that's horizontal siding. And then they're trimming around the windows that have already been installed and taped and everything in our factory. So that's not something that they have to worry about. And at that point, there's really no reason to go back, depending on exactly how we finish the soffit. We don't do soffits typically. So it's going to be open because we do a cold roof design. So it's monopoly framing, and there really aren't any voids, which is a great thing in, places where you have fire danger, because there's no places that are sucking in sparks or anything or embers in the way that we put our buildings together. And so you really could have someone working on the roof at the same time. It just depends on how big the crew is. So assuming it's a simple house, it happens pretty stinking fast. They move around it. And so everything else that happens, all of that finish work, the detailing, the final carpentry, the plumbing, the electrical, all of that gets to happen in this closed in, super insulated space. And it is a delightful place because you can keep the place warm with a hairdryer. So does it take a lot of energy to create this really high performing shell and then allow existing building trades, ideally people that live in that area, to have this beautiful space that they get to work in for the rest of the finishing of the house. One of the things that we've been trying to do is say that we're not trying to steal jobs from the location where that house is assembled. We're trying to make the cruddy or the hard jobs better so that the people that are the trades folks that are coming into that area have a better place to be able to work in.
Yeah, I like that analogy there. And so just dumbing it down to like quantifiable numbers. So let's say a normal single family home is going to take 6 to 8 months of construction, right? At least in our neck of the woods for your average house. What do you think a timber age home takes in comparison? From like the foundation, from like first scoop into the dirt to keys to the homeowner.
I'm just going to make the assumption that you have a crew of 4 that's able to stay pretty focused on it, and that we're talking about a 12 to 1,400 square foot 2-story house. An experienced crew will probably break ground to have that house move in ready, assuming that all the other scheduling things of trades and all that work out. I think it's 2 months. It's 2 to 3 months, which is, it's just really fun.
Yeah.
It's really fun to think about.
Yeah. That's, I was honestly kind of expecting you to say, okay, let's take it from 8 months down to 6, but not from, 8 to 2, right? Like
no, and really like one of the biggest challenges that we've had is that we'll call a tradesperson, they'll do a component of their work, and they're not used to being called back for 3 to 5 weeks. And so they build their schedule that way. So that's why I preface it that if you have the people and they understand that they can probably stay there and just stay engaged, it can happen relatively fast. One of the biggest problems is that people show up, do something, and then leave, and then they've scheduled 4 other jobs before they can come back, because that's how long they usually have. So it happens so much faster. It's kind of surprising people where you're like, oh, you're ready again. Shoot, I should have just stayed there.
Yeah. And so that kind of goes into like the planning and considerations that are different using a prefab panelized system like yours versus like a stick frame. So we talked about like, hey, trade schedule alignment, right? Like let them know that this is going to be different. We need to schedule appropriately. what other major considerations do design and build teams or even owners need to consider when using a system like yours that they might not think is different than using like a stick frame?
In the world of construction, the best of productivity, operational excellence has made it into the world of construction. So there's a Lean Construction Institute, and APA has, an integrated project delivery kind of outline. So integrated project delivery is the way that the construction world is thinking differently about the way that all of this stuff happens. It usually just happens at really big scale. So I would say the biggest challenge is to say it's a house, getting all of those people together to watch the videos and talk about sequencing and sign up for when they're going to arrive and do the work before you've started construction is a weird thing for people to go through in the residential world. But if you can get those people to do it, it makes all the difference. What we're usually doing is the GC starts construction and the electrician has never thought about the job or talked to the people that they might be working next to before they show up to start doing work. And so when we talk about that, elevating communities and healing the environment through innovative materials and methods, the methods component that we're really using our construction type to try and drive is it's so worth getting everyone in the room before the job starts. And it's worth paying them. If they're like, I need you to pay me for my time if I'm going to show up, it's worth whatever it is. If it's $1,000 or $2,000, budget it so that you can, in the world of manufacturing, you might call that Obeya. It's a Japanese word that means the big room, but it's the big room that you get everybody into that you can see everything that's going to happen, and you let everyone have the conversations about what it looks like to understand who goes first and who goes second and who goes third. If you can get that at a high level and let everyone be on the same page when the job starts, it ends up being this thing that is tremendously fun and life-giving. And it is not something that people are just walking in and mad at the next person or mad at the person that came before them because of clashes from a design standpoint.
Yeah, I like that. Moving towards the end here, I want to ask you stuff about what working with you looks like, right? So it's like, I'll just get into it. So if people that are listening and watching like what you're talking about and they want to learn more about working with TimberAge for their next home, what does that process look like from them, from reaching out to engaging with you guys on a commitment level?
Yeah, if you want to build a TimberAge house, first and foremost, we definitely have design, builder resources, but more than anything, we really want to make sure that other people come into the fold. And so I think at the very least, the first thing you have to decide is, are you going to use a pre-existing design or are you trying to do something that's site specific? So assuming that that maybe you already have a design in mind, you can come to us with that design very quickly. You can go to timberage.com, you can upload the design, and we can give you a value proposal that helps you understand, at least at a very high level, go, no go, here's what that shell is going to cost. If you need a design resource, that might be something that you do. So we might, give you someone, but we would love to work with professionals that you have in your area if that's possible. If you don't have them, then we'll try and help you find them. So the first thing is, are you going to start with something that you've seen before, or that maybe you want to find out if we have repeatable designs that might work, or are you going to do something from scratch? Either way, we can get to a price relatively quickly because we've designed the system to be priced off of just a shell or a massing diagram. So you can get to a TimberAge price really, really quickly, and then we can work out the details. So our job is trying to help you, first and foremost, does it fit your budget? And then how do we refine? One of the things that we offer or that you can do is we typically will do a drone survey at the site. And the reason why that's helpful is now everybody can do everything visual from the earliest point possible. And we get to use that when we're thinking about solar studies and laydown areas and crane locations. And you get that to be able to plan with all of your folks. So we use drone surveys and 3D models of the site as early as possible because it just helps us, avoid missing things. Let's say that you really like that value proposal and we give you a ceiling. So we're going to give you a not to exceed kind of agreement. You sign that. Your first 10% of that grabs you a production spot. So we'll tell you, here's the openings that we have. You put 10% down. We reserve that for you. And then we start the process of working from design lock, which is a period usually 4 to 6 weeks before we would start production, that makes sure that we're ready to start ordering materials and we're not going to change the scope of the project. We work backwards from that and we'll set a schedule that lets us make sure that we have a model that you're comfortable with from a floor plan and that we're comfortable with from a detail standpoint. And so one of our partners is going to create a 3D model of that. We use that 3D model to reference all of our discussions. Once we've locked that down, it moves into a position where we just break it up into pieces. You give us the next 40% of the amount. We would revise the value proposal if we needed to at that point. And then we start production and we start billing against the retainer that you've given us. Once we use that up, we give you an invoice every week that's due 30 days later. And by the time that the thing shows up, the last invoice that you get is what it costs us to ship it to your location. And right now, that process, we're booking production in spring to summer of 2026. So like right now, if we can get a line and you place an order, we're probably delivering you a house in May or in July or whatever.
Okay. The last couple of things I'm going to prompt you on is just internally, do you guys have like a document, a PDF, something that kind of like overviews this process, like whatever, like step 1 to step end that you already give out to clients? Do you already have something like that?
We do. If you go to timberedge.com and you click on I want to design something, you can sign up. We'll send you a copy or a link to our design guidelines. And that's a document that's continually updated with all of the information that you need, at least at a very high level to understand, or you could give it to your architect and it helps them understand basic dimensions and constraints for the way that they would design something.